This video is going to address how to graph a hyperbola given the equation of a hyperbola in whatever form it happens to be. So with that in mind, I'd like to give you an example of a hyperbola and then sort of walk you through all of the necessary steps to graphing the hyperbola. So let's start here. Let's do x squared over 9 minus y squared over 25 is equal to 1. In order to graph the hyperbola, you're going to need to know three things. And those three things are going to be what is the center, what is the orientation, and just the values of a and b. It's not necessary to have the value of c for this one, and I'll explain why as we go along. So first off, for the center, we take a look at the x variable and the y variable, and we see that there is nothing being added or subtracted from these variables before they're being squared. That's indicative of a center located at the origin. I also see that it's the x variable that comes first, and because the x variable comes first, this allows us to draw the conclusion that this will be a horizontal transverse axis, and that our value of a squared is going to be equal to 9. That also lets us know that our other denominator, well, that's going to be b squared. Oh no, we're losing the red pen. Oh no. So with those things in mind, we just said that that means a horizontal transverse axis. We can arrive at the conclusion that a is going to be equal to 3, and that b, with b squared equals 25, b will be 5. Now, these two are going to allow us to get our vertices and our co-vertices. Allow me to explain. So first off, I'm going to plot my center right here, and I'll say that this point is going to represent 0, 0. I did not bring graph paper with me today, and that's okay. So starting from the center, because it's a horizontal transverse axis, if I move left and right a total of 8 units, so 3 units, 1, 2, 3, I will arrive at a vertex. So there will be a vertex here at 3, 0. And then 1, 2, 3 to the left. There will be another vertex here at negative 3, 0. We also need the locations of our co-vertices. So starting from the center, we're going to move up and down a total of b units. So that's 1, 2, 3, 4, 5 units upward. That's a co-vertex here at 0, 5. And then we'll also go 1, 2, 3, 4, 5 units down for a co-vertex at 0, negative 5. Now we do see the horizontal transverse axis here with the vertices and the center on them, and we know that somewhere beyond the vertices on either side we'll have our two foci as well. It's not necessary to have each focus in order for us to graph this thing. Instead, what we'll do is we will create what is known as the box. The box is what you get by starting at the vertices and co-vertices and connecting them either horizontally or vertically using line segments. Just going to create a nice little box. Just a happy little box. It's easier for me to reach across like this. There we go. So horizontal and vertical line segments passing through the vertices and the co-vertices. Now, for the record, if I were to draw something round-ish that passed through all of these vertices and co-vertices, then we would have exactly the ellipse that would exist in here. However, an ellipse geometrically is not the same as the hyperbola. So here's what we do instead. We are going to create a pair of oblique asymptotes. Oblique asymptotes. This is the one graphical aspect that we don't see associated with the ellipse. So instead, a hyperbola is defined in terms of a pair of slant asymptotes or oblique asymptotes. So the asymptotes are going to be the two diagonals of the box. Let's see if we can draw that a little straighter. So we'll go ahead and extend those outside of the box itself. There's little dashed lines here, like so. And we will extend those as far as they need to go. So the idea for the graph of a hyperbola is that we are going to pass through a vertex, curve around a focus, and approach the asymptotes. Again, asymptotes are lines that we approach but don't necessarily touch. Now, we could do the math on this and figure out exactly where the focus is. I'm not entirely concerned with that at this juncture, though. So what we'll do is we'll pass through a vertex and we'll curve around a focus, and we will approach the asymptotes without actually touching them. And this is the most accurate depiction of a hyperbola that you're going to get. I did a lot better on this side than I did on the right side. This one looks more aesthetically pleasing, though. That's great. So one of the big things that you're going to encounter regarding the asymptotes is, can you figure out either the equation or the slope associated with the asymptotes? Now, in this case, when I say the slope of the asymptotes, I do want to point out there are two of them. One of them has a positive slope going up as we go to the right. One has a negative slope going down as we go to the right. Now, with that in mind, they are the same numerical slope. One is just positive and one is negative. So plus or minus. And we know from our study of math and algebra classes from way back when that a slope is simply a change in y over a change in x. And if that's all that you want to remember, fantastic. You know everything there is to know about slope. However, in the context of what we're doing here, in this case, we created our change in x and our change in y based off of the box. And the box is based off of the vertices and the co-vertices. So in this case, what we're saying our change in y is technically our b value, and the change in x is technically the a value. So plus and minus b over a is what this would be for the horizontal transverse axis. Now, in the event that you're dealing with a vertical transverse axis, the slope is still going to be plus or minus the change in y over the change in x. However, because of the reversed orientation, a would then refer to a change in y, and b would refer to a change in x. So this is specifically for the vertical transverse axis. I have the darndest time trying to remember which one of these goes with which. If you are a memorization kind of person, go for it. That's not how I operate. What I need to do is actually copy down all this stuff up here to remind me which number goes with which orientation and which variable, and then I just kind of piece it together from slope is supposed to be a change in y over a change in x, and just match the appropriate distance with the appropriate variable. Whatever works for you, I say go for it. So the important thing about your asymptotes is the asymptotes are defined in terms of a slope and a point. The one point that is common to both of the asymptotes, it will always pass through the center. Not necessarily the origin, but the center. So when it comes to your oblique asymptotes, the point on both of these is going to be the center, and the slope is going to be equal to plus or minus change in y over the change in x. Maybe it's b over a, maybe it's a over b. It depends on the orientation.